Good morning, YouTubers. My name's Richard Wilkinson, and I'd like to talk you through how to create an Oxford bell. Oxford bell was created in 1840 and has been running for 185 years, which makes it one of the longest battery-operated devices in the world. We think it uses Zamboni piles, and probably about 2,000 of them, giving a voltage of around about 1500 volts at a few nanoamps. So that's why it's been running for such a long time. So I'll go through all the processes of how to create the Zamboni piles, and then that will then allow you to create the Oxford bell for yourself. So hope you enjoy it. Catch you soon. So the first stage of making the Zamboni pile is to use a piece of aluminium foil and a piece of white duplicating paper. So this will make about 140 cells. So we start off by applying the PVA glue. So we've put the all the PVA glue on now, so we just need to put the piece of A4 paper, line it up, and then that sticks hopefully well onto that. And then we need to leave it to dry for about 24 hours and before we put the manganese dioxide onto it. So the 5 grams of manganese dioxide, half a gram of graphite powder and a sprinkling of wallpaper paste are all mixed together and into quite a thick paste. Don't make it too thin, and this will be enough for to do an A4 sheet of paper. So we're ready now to put the manganese dioxide and graphite onto the A4 piece of paper. I get a reasonable dollop of the manganese dioxide, and it sort of press quite hard on it. It tends to skid across if you don't press hard onto it. It's a bit of a funny stuff to use. So we'll put one coat on and let it dry, and then we'll put another coat on afterwards. So we've now covered the A4 piece of paper with the manganese dioxide and graphite compound. It's looking a little bit patchy, so we've got to let it dry for a little while before putting another coat on. Just a word of warning, manganese dioxide can cause problems with your lungs, so you should really wear a mask when using it. Okay, the sheet is now covered with aluminium on one side and manganese dioxide on the other. It's now time to cut them into strips. So I use something that's about 21 millimeters wide, and I just score it with a pencil and then cut it using scissors. An article written in 1952 said that the cutting is the most important thing. I've tried a scalpel, but find the scissors are the best. Each strip is now cut into 10 squares, and each square will have a voltage of about 0.9 of a volt when it's new, and probably go down to about 0.75 after a couple of months. So the next stage is to test that we are getting that sort of voltage. Okay, we're now going to measure the voltage of the Zamboni pile. There are 30 cells in here, and I've put it into a clamp with aluminium cheeks either side, and off camera is a 47 nanofarad capacitor just to help with the measurements. So the 1.5 gig ohm resistor going into the 10 meg ohm digital meter is going to give us a ratio of 1 to 150. So we can now measure the voltage on the Zamboni pile, and you can see that it's 0.2 of a volt. 0.2 of a volt times 150 is going to give us 30 volts, which is just about a volt per cell, which is very good. Right, so we've now got 110 cells in the pile now. So we'll just test the voltage again to see what it is now. So we've got 0.69, so that's 0.69 times 150. So that's 103, just over 103 volts. So that's what we've got in our pile at the moment. So all the cells now have been put into a small box, and this allows me to continue to measure each small Zamboni pile, so I can see how it changes over a period of time. So the top of the box is open, and you can see that you can compress the cells by putting a piece of tape round the enclosure. So there's aluminium cheek there and aluminium cheek there, and then the capacitor is the same as we've used before, the 47 nanofarad capacitor. For the final version, you probably don't need to put it in separate little boxes, and probably you could put 500 into one box. So for the final version, probably need about 10 of these small boxes, giving somewhere around about 900 to 1000 volts. So just to prove that we've got something like 70 volts, probably more like 100, I'm going to show you that it will actually flash a neon bulb. Here you go. Right, we've now got to a point where we've got 10 small Zamboni piles, making a full Zamboni pile for the Oxford bell. I've just measured the voltage and it's 870 volts, so that's should work quite well with the bell that I've made. You'll find that the cells do change with humidity and temperature, and that's one of the reasons why I want to continue to monitor them to see how well they last. So the next video will be the Oxford bell actually working. So the Oxford bell is now connected to the Zamboni pile, and I've just measured it and it's about 870 volts. The way it works is that when the ball or the cylinder touches, say, the positive side, it picks up the positive charge, gets repelled and gets pushed over towards the negative, which then does the opposite and then pushes it back to the positive again, and this just keeps going. So the bells are from bicycle bells from AliExpress, and we'll see if it carries on going for the next 185 years. The thread is about 30 centimeters long. So thank you for watching, and I hope you enjoyed the video.